All right, so here's the first problem. Again, just listen so you understand. A bag contains a total of 48 marbles. The marble colors are red, blue, and green. If you randomly choose one marble from the bag, the odds of you drawing a red marble is 1/4, and there is a 50% chance of drawing a blue marble. How many green marbles exist in this bag? So let's write down just the facts. We know that there are 48 marbles in all. We know the colors are red, blue, and green. The odds of you drawing a red marble is 1/4, and the chance of you drawing a blue marble is 50%. And the question says, how many green marbles are contained in the bag? So how do we do that? Well, we know that the bag contains 100% of marbles. So if I take 1/4 on the calculator, if you're not familiar with what 1/4 is a percentage, take 1 divided by 4 on your calculator, and your calculator should say 0.25, which is 25%. So 25% plus 50% is 75. 100% minus 75% leaves the green with 25%. 25% of the marbles in this bag are green. Please take 48 times 0.25, 48 times 0.25, and the answer is there are 12 green marbles in the bag. Going on to the second question. According to last year's data, taken from the 5 sections I taught in Algebra 4, the chance of passing tomorrow's probability test is 89%. What is the chance of a student not passing tomorrow's probability exam? Turn to your partner, go ahead. And the answer is 11%. We know in all there's 100% of students are considered. 89% is the pass rate. So if 89% of students pass, that means that 11% of students did not pass last year, so your chance of not passing is 11%. Okay, I'm moving on to the next problem. So this is a review from yesterday. Please write this down. So I'm going to give you a universal set, and the universal set is all integers from 0 to 13. All integers from 0 to 13. And I'm going to let you know that within the universal set, we have set A, which is 0, 1, 3, 4, and 7. Set B is 2, 3, 5, 7, 8, and 11. And set C is 0, 3, 5, 7, 8, 11, and 13. The first one we are going to, the first set we are going to find out is I want to know this statement. So first we have to go, what does that mean? So we have to know what is A complement, and then we'll take the intersection with set B. So A complement, how do I get A complement? It means I look through all of the integers 0 through 13, but I need to eliminate the integers that are the ones included in set A, which would leave me with, so I can't use 0, 1, I have 2. Okay, can't use 0, 1, 3, 4, 5, 6, cannot use 7, 8, 9, 10, 11, 12, and 13. There is the complement of A. Now I want to intersect that with B, so I'm going to put B right below it because of spacing off to the side. 2, 3, 5, 7, 8, 11. Intersect means what do they have in common? They both contain 2's, they both contain 5's, they both contain 8's, and they both contain 11. The answer to this is 2, 5, 8, and 11. Okay, next up, we are going to do A union C, and then you're going to see a complement of this. A union C with a complement. Let's first figure out what is A union C. Remember that union is we're pushing together, but we're not going to repeat numbers. So I'm pushing A and C together. Okay, we have a 0, we have a 1, I don't see a 2 in either set A or set C. There is a 3 and a 4, a 5, I don't see a 6 in either one. We do have a 7 and an 8. Notice that there's a 7 in both, but I'm not going to repeat it. There's no 9 or 10. There is the 11 and a 13. Well, I do the second part of this problem. I'd like you to do it with your partner and talking. Please find the complement of this set. Does anyone have questions about this? Does anybody have questions? Okay, we have one more type we're going to do with this one before we move on. Here's your last one. I'd like you to do B union C, and then I'd like you to intersect that with a complement. Remember, there's 3 different ways to write complement. Line above, the accent symbol, or the small c. So let's push A and B together. Oh, thank you. B and C. B and C. So I have 0, 2, 3. Don't repeat the 3's or the 5's or 7's. 5, 7, 8, 11, and 13. And I'm going to intersect that with the complement of A. So everything in 0 through 13, excluding these values. 2, 5, 6, 8. Okay, so what do these two sets have in common? That's what intersection means. They both don't have a zero, but they have a 2. No 3's, we have a 5. No 6's, no 7's, we have an 8. We have 11, and we have a 13. So this answer is the set 2, 5, 8, 11, and 13. And we are done with that section. What if I asked you this? I tell you that the probability of event B occurring is 0.5991. What is the probability of B complement? With your partner, you have 5 seconds to begin. So remember, really, when you say 100%, that's really 1.0 as a decimal. So you're going to take 1.0 minus the probability of A. And the answer is 0.4009. Just so I'm aware, we're done with one page. So I'm aware on a 1 through 5, what is your comfort level so far with these problems? Okay, most of us are 4s and 5. Let's go on to the next part. Okay, I'm going to tell you, whoops, 1 second here. I'm going to tell you that we have P of A is equal to 0.2. P of B, we do not know. And the probability of A and B is 0.7, it's my fault, 0.072. 0.072. So what do you have to know in order to solve this? You have to know that when you have an AND statement, and you're, by the way, you're also told that A and B are independent events. When you have an AND statement, you are multiplying. So P of A and B, knowing that they are independent, is the probability of A times the probability of B. I know this answer is 0.072. I know this answer is 0.2. I don't know this answer, so let's call it x. If we want to solve for x, let's do the inverse operation and divide by 0.2. Please do that for me on a calculator. And your answer is 0.36. Problem done. If you have a packet out from yesterday, please flip to the back. Okay, so this time, we are going to do a problem. Let me zoom in here so everybody can see it. Give me 1 second here so it's visible to people in back. Thank you. So we have two different containers, both containing peppermint and butterscotch candies. Container 1 contains 6 peppermint and 4 butterscotch, and container 2 contains 5 butterscotch and 3 peppermint. My question for you is, what is the probability of first choosing, so the probability of choosing a peppermint from the first container and a butterscotch from the second? Now, before we do anything else, we have to ask ourselves this. Do we consider these two events to be independent or dependent? We want to choose a peppermint from the first container and then go to the second container and choose a butterscotch. They are considered independent events because the probability, the first event has no impact on the second event. So that's why they are independent. So how many peppermints do we have in the first one? 6. How many total? 10. Okay, and means we're going to multiply. We know they're independent. So how many do we have in the second one? We have butterscotch is 5 out of 8. Let's pretend the problem said that you had to reduce your answer as a fraction, or write the fraction in lowest terms. So we are going to go ahead, put it as a fraction, and then math fraction, enter, and the final answer is 3/8. Couple important things for this problem that you have to be aware of is, 1, can you determine if they're independent or dependent? And then how do you write your statement proving? Again, these two are independent events because the first event has no impact on the second event. Okay, let's do another problem like this. But now let's say that we only have one container. So this time we only have one container, and I'm just going to go over the top of this, and let's say that this container is the one described as the first container, okay? So you have one container. In that container is how many? 6 peppermint and 4 butterscotch. So here's my question for you. What is the probability of choosing a peppermint and a butterscotch when you do not replace the first one? So there's no replacement. Well, we know with AND statements we have to multiply, but when there's no replacement, that means it's dependent. And the reason is because the first event impacts the second event, okay? So how many peppermints do we have? 6 out of 10. But we don't replace that. So we randomly get a peppermint, great, we put it in our pocket. Now the second time we go back into the container, we're looking for a butterscotch. How many are there? 4. But it's not 4 out of 10 because you kept one candy in your pocket, making it 4 out of 9. Please write that as a fraction in lowest terms. The answer is 4 out of 15. Thumbs up, thumbs down. Okay, I'm going to say the question again. This time, please do it by yourself. We'll practice. So let's use the exact same candy container. And we will say that this time you want the chance of getting a butterscotch and a butterscotch again. And you are going to replace the first candy. Go ahead. Your fraction as an answer in lowest terms is 4 over 25. How do we get that? 4 butterscotch out of 10 total. But then after you choose that first candy, which happens to be butterscotch, you put it back in, you're replacing it. You go back in again, there happens to be 4 butterscotch. 4 out of 10 again because you replaced it. Reduced fraction is 4 over 25. Thumbs up, thumbs down. Is this last one an example of dependent or independent? Okay, here's my question. Does your first event impact the second event? Because when you replace independent, when you do not replace dependent. Okay, we're going to move on right now. Give me 1 second, please. This time you'll write down this problem here. Start by just writing these down for me and then I will explain. You have 100 seniors, 200 juniors, 300 sophomores, 400 freshmen. The names of all the students listed of the 100 seniors, 200 juniors, 300 sophomores, and 400 freshmen are placed into a large container. And you are randomly going to draw 3 names out. I want to know, without replacing a name after it's drawn, what is the probability of drawing a senior and a junior and a freshman in that order? And statements, do we add or do we multiply? Okay, so I know I'm going to multiply. Now my question for you, is this dependent or independent? Dependent because what are we doing? We're not replacing. So tell me how many seniors we have. We have 100. Now how many total students do we have? Okay. And we are, by the way, we're going to round our decimal to the nearest thousands, just so you know on our final answer. How many juniors do we have? 200 out of, not 1,000, because we didn't replace. And then how many freshmen? 400 out of, I know this is going to be a large number. I'd like you to round to the nearest thousands. Go ahead. There has to be somebody that's going to say, Miss, what if I do the answer? I get the right answer, but I don't read the question. Instead of following the directions and writing your answer in reduced fraction form or rounding to the nearest thousandth or nearest hundredth, will I still get it wrong? And the answer is yes. Okay? Make sure you read the directions carefully. Can I have a thumbs up or thumbs down for this problem just so I know where we are? Can everybody participate with thumbs up or thumbs down so I know? Okay, we're moving on to the next one. Okay, this is going to be a difficult one. Give me a second, please. A lot more writing. Okay, so you're going to write this one down with me. Let n be a randomly selected integer. Oh, I got to zoom out here so everybody can see. Give me a second, sorry. Let n be a randomly selected integer from 1 to 54. what is the probability that n is a multiple of 12 given that it is a multiple of 4? I would like you to circle when you're done the given statements. Okay, this is where you have to start. So we're going to start by writing down all the numbers that are multiples of 4 from 1 to 54. Please do that with me. You can go as fast as you want. This is our base set. This is all we care about to start with, is what are the givens. So I wrote down all the numbers again from 1 to 54 that are multiples of 12. Now the question is, what is the probability of randomly selecting from this group a multiple that is, a number that is a multiple of 12? So multiples of 12 would be 12, 24, 36, and 48. I know there's 4 of them. How many total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Written as a fraction in reduced form, it would be an answer of 4 out of 13. Who would like to try another problem like that? Okay, let's do another one. This time, let's have you do the numbers 1 through 20. So I'm not gonna write all of this down. So let n be a randomly selected number from 1 to 20. What is the probability that n is even given that it is a multiple of 5? Once again, let n be a randomly selected integer from 1 to 20. What is the probability that n is even given that it is a multiple of 5? Let's go with your partner. Change up what I said. Do this problem with your partner. Write your answer as a fraction in lowest terms. Go. Does anybody have a question for me about this? Anybody? Okay. Eyes up here. I need to zoom in for this next problem. Give me a second. I'm slightly changing up the problems you have so you have more problems to practice. I'd like to zoom into this one. Give me a second. Thank you. So here's the question for you. It is slightly different than what you have in your paper, just so we have more problems to practice. At a small school, there are 80 girls in the senior class. Some of them play basketball, some of them play soccer. Oh, sorry, we're on the wrong one, aren't I? How about this one? After returning from summer break, Aaron surveyed 32 students in his advisory class. Some of them went on vacation with their families, some of them worked, and some of them did both, and others neither went on vacation or worked. If you know a student did not work, what is the probability that they also did not go on vacation? Please write that down. If you know a student did not work, what is the probability they also did not go on vacation? So here's where this is sometimes a little confusing for students. They didn't insert the word given, but there's a given statement here. What is the given? What do you know for sure? Okay, so circle, they didn't work. So in this problem, I need to find out where does it say they don't work? No work. Now that's the only section I'm focused on. Now in that section, we want to find the probability that they also did not go on vacation. So no vacation out of a total of 14. So 4 out of 14, if they asked us to write this as a fraction in lowest terms, it would be 2 out of 7. Make sure your partner understands this. This is a little more confusing for a lot of students. At this time, I'd like you to flip and find number 13 in your packet. Flip and find number 13. Okay. So I'm going to fill in the numbers here. You should already have done this last night, but you can check your work here with this. These numbers correspond to the information that's above. So I am going to change the wording for part B just so we have additional practice. Yes. If it's emergency, otherwise no. Okay. Of all those who purchased a car, what is the probability that a randomly chosen buyer is a female and they purchased an SUV? So the key is of all those who purchased a car. So how many total people purchased a car? So I know my bottom number is 66 of all those who purchased a car. Now we need to find out where does women and SUV intersect. So women and SUV intersects at the number 24. And if they asked you to write this as a fraction in lowest terms, the answer would be, I'm going to do it here, it'd be 4 out of 11. Please make sure your partner understands before I go with the next problem. Okay, here's your next one. Again, I'm making up something similar to part C, but slightly different so you have additional practice. This is similar to part C of number 13. Given that a randomly selected buyer is a female, what is the probability that a sports car was purchased? Please give me a fraction in reduced form. With your partner right now, go. Given that a randomly chosen buyer is a female, what is the probability that she purchased a sports car? Turn around, Alexis. Okay, so we're given that she is a female. So this is the given. How many sports cars? 6. How many total? 30. And then reduce 6 out of 32. 1. Nice job. Okay, the next one is rather difficult. Take out that blank piece of paper. Give me a chance to flip this around. We are now going to start doing problems that involve playing cards. More than likely, you will want to write this problem down. Alexis, are you focused? Okay, so you are playing with a normal deck of cards. Everybody understand that? Normal deck of cards. And I want to know, do you have a greater probability of choosing a 10 and then going for a second drawing and choosing a 10 a second time with or without replacement? And you have to prove it using math. So I'm looking for, let me move down here, I'm looking for what is the probability of getting a 10 and a 10 a second time. And I want to know, do we have a greater chance of getting this if we do replacement or if we don't do replacement? And we have to use math to prove this. Okay, so let's just write down, let's label these. Let's do replacement first and no replacement second. And then after we do the math, we'll make a statement on which option gives us a better chance of getting a 10 and then a 10 again. Let's do replacement. So with replacement and statements, how do we do and statements? Okay, so how many 10s are there in a normal deck of 52? 4. How many total cards? 52. Okay, you randomly choose one, hey, it's a 10. But then you replace it, you put it back into the deck, and you go after a card again, and you're looking for a 10. How many 10s do you have? 4. How many total? Can you please multiply and round this, let's say, to the nearest, let's go 4 places after the decimal. Now no replacement, let's start again. So this time, you're looking for a 10, or you're hoping for a 10. You draw a card, woo, how many of them are going to be 10s? 4 out of 52. But this time, you randomly get that card as a 10, you put it in your back pocket. Now you go for a second drawing, and you're hoping for a 10. How many 10s still exist in the pile? Okay, we have 3 10s existing. How many total cards? Okay, same thing please. Multiply, rounding 4 digits past the decimal. So which one gives us a better opportunity to draw 2 10s? Replacement. So after you show the math, you could say you have a higher probability of drawing 2 10s using replacement. But I have to be able to see this math to back up your answer. Thumbs up or thumbs down with your understanding of this? Okay, good. We're going to go on to more card problems. We're only going to draw 1 card this time. And we have a deck, a standard deck of 52. Please write this down. What is the probability of drawing a 3 or a 5? We're going to do 1 drawing. Now with OR statements, you are adding. What you have to decide, is there any overlapping that occurs? So on a standard deck of 52, are there any cards that are 3s that are also 5s? No. Okay, so there's no overlapping. So how many 3s do you have in a deck?
1.
And we're going to add how many 5s? Please write your answer as a fraction in lowest terms. The answer is? Let's go back to more cards. Let's say this time, what is the probability of you're going to make 1 drawing, of a 3 or a spade? Is there any overlapping?
Yes.
Okay, so how many 3s do you have?
4.
And how many spades? How many spades, guys? 13. Remember, there's 13 from every suit. And now we need to subtract the overlapping. So what they're asking is, how many spades are also 3s? Make sure to use parentheses when you do the math. Please write your answer as a fraction in lowest terms. The answer is 4 to 13. Thumbs up, thumbs down right now with your understanding. Sure. So here's what your calculator should be able to do it, but what I would like to see you do, just to ensure you don't have any mistakes, is you're going to go like this. Oh, so sorry. Like this. So I'm using parentheses as I go. Does that make sense? Okay. Give me 1 second, please. I would like you to turn in your packet, and I would like you to look at problem 15. They're talking about musical instruments, no musical instruments, playing a sport, not playing a sport. Please look at part A and part B. I'm not requiring you to do the problems. What I'm asking right now is, can you and your partner please make sure you understand how to complete A and B? Go ahead. Okay, I'm going to stop you because, again, I don't care right now if you have the answer or not, but what I do care is you understand how to get it. What are you going to be doing with the numbers as you go through like their flow chart? You adding them or multiplying them? Okay, let's do one more card problem just because you guys are struggling. Okay, so you have a standard deck of 52 cards. You randomly select 1 card from the deck. What is the probability that it is black or a face card. With your partner, do this problem. What is the probability that is black or a face card? Please make sure I see you talking with your partner. How many black cards are there?
36.
I don't think there's 36. Oh, 26. There we go. I agree, 26. There are 13 clubs, 13 spades. So 26 out of 52. How many face cards?
12.
There are 3, 3, 3, and 3, which is 12. Thank you. And now how many overlapping do we have there? Face cards and also black. Okay, make sure to use your parentheses as you complete this problem. And this time, let's do it this way. Let's do a decimal rounded to the nearest hundredth. Natalie, you awake? We're going to move on to number 17 right now in your packet. 17 is going to be a game changer for many of you. Remember this, 15% of your grade is homework, 15% is checkpoint quizzes, 70% of your grade is exams. You have one class period to take this entire, did I do something wrong, Luis?
No, I had a question.
Can I get done first? You have one class period to get this entire exam done. This will be the last problem you have on your exam. And this problem on your test, this is worth 4 points here. Each one down below is 1 point. So there probably is not even a chance of you getting an A if you don't get to this problem. Okay, got it? So we're going to do it together right now. You ready? All right, so I know we've already done this problem, but it's good practice for us anyway. Luis, can I get this done first and then answer?
No, you answered my question already.
Okay, so here we go. We have 40 students in all. So I know when I add all these up, I have to get to 40. And we have two types of subjects here. We have AP English, and we have honors chemistry. Now we know in all there are 14 students that take English. That means between this section and the overlap, they have to add up to 14. And likewise, we have 29 in chemistry, so between this overlapping section and to the right, they have to add up to 29. Now there's 2 that take neither, so put 2 right here. So if 2 of the 40 are not even in AP English or honors chemistry, that leaves us with 38 in this section. Does everybody understand that fact? Yes. So I know 13 are in English or chemistry. So let's make an or statement. Probability of English or chemistry. Okay, remember with or statements we add. So that means the probability of English plus the probability of chemistry. And when we're adding, we have to add ourselves, is there any part that's going to overlap? Yeah. So when there's overlapping, we have to subtract the intersection of the two. For your test, underneath this section, I left you about 3 inches so you'll have room to show your work to get your answer, okay? All right, so how many are either in English or chemistry, knowing that 2 are in neither, and there's 40 total? 38 out of how many? So let's go 38 out of 40 are in English or chemistry. I know that English itself has 14 out of 40. And I know that chemistry has 29 out of 40. And I want to know what is the overlap. So I'm going to do subtract x. So first I'm going to add up the 14 out of 40 and the 29 out of 40. And we end up with 43 out of 40. And I want to take that positive 43 out of 40 and I want to subtract it to the other side. So it looks like 38 out of 40 subtract 43 out of 40 is equal to negative x. Again, I combine these two, and I'm going to, they have a positive 43 out of 40. I'm going to subtract it to the other side so that I can isolate the negative x. Okay, so now I have this system. Since I have a common denominator, I know I can just take 38, subtract 43, which is negative 5 out of 40 equals negative x. At this point in your math query, you know that I can divide both sides by negative 1 or multiply both sides by negative 1, and x is equal to 5 out of 40. What did I just solve for? I just solved for the intersection, so put a 5 right here. Up above it says there's 14 total students in English. Well, if 5 are in this part of the English, how many have to be here to add up to 14? And there's 29 in chemistry, so 5 here, that leaves you with, if you can do that, you can do the rest, or at least get the majority of them right. Okay, here we go. 2 students in the club are taking both, true or false? 24 students are taking honors chemistry, but not AP English. 24 students are taking honors chemistry, but not. That's true. You guys are faster than I am. The probability that a student is in AP English or honors chemistry. So our or statement was right here. Can you please divide 38 divided by 40 for me? That's our or statement. And can you please tell me, is that equivalent to 0.95? Yes. The probability that a student is taking both classes, so please take 5 divided by 40 for me and tell me if it's equivalent to this decimal. Yes. The probability that a student is in AP English but not honors chemistry. The probability that a student is in AP English but not honors chemistry. Okay, so do you think that is a true or false statement? Okay, turn to your partner. How do you think it's false? How did you get your answer? Who would like to explain their answer for me? First hand up, so we can get done with this today. Jesus, what do you have?
So I divided 9 by...
Slow it down. What did you divide?
9 by 40.
And why did you choose 9?
There's only 9 English students.
That are in AP English but not chemistry by 40. Is 9 divided by 40 equivalent to 0.35?
No.
A randomly chosen student is more likely to be in both classes than neither. Well, both classes is 5, and being in neither class is 2. So is it true that you're more likely to be in both classes than neither class?
Yes.
Okay, the probability that a student is in AP English, given that they are in honors chemistry. So first of all, we're focused on honors chemistry. Put a circle around this. How many students do I have in honors chemistry?
24.
No. How many students do I have in honors chemistry? 29. So 29 is your bottom number. It's your denominator. What is the probability that the student is also in AP English? It is? So please take 5 divided by 29 for me, and let me know, is 5 divided by 29 equivalent to 0.225?